This is sigma notation notes. Sigma is this Greek letter. It's a capital Greek letter. It looks kind of like an E. And sigma means sum. Now, this is not in your book. This is something that's expected to know before going into statistics. So we want to make sure we go over this, and then we're going to go over the round-off rule later so that you know where to round as you calculate things. So those are two sections we kind of do before we get into actual statistics book. So this, you can draw it like this, kind of looks like an E. It means sum. It's telling you some formula you're going to do a sum of. So whenever you see this shape, this sigma, capital sigma to be specific, you need to be thinking sum. You're going to be adding things up. Remember that sum means add. Okay, so then we have this cool formula here that we follow. It tells us, so we'll have a formula, it's just an equation, so you're going to plug things into the formula. This formula is usually an algebraic expression that we use. Then you're going to have two numbers. The bottom one is where you're going to start, the top one is where you're going to end, and we count. So if we had the sum from x equals 1 to 4 of x. That means we're going to plug in the numbers 1, 2, 3, 4. You count by ones up to that. And we add them all up. So I'd plug in 1, plug in the next number, which is 2, plug in the next number, which is 3, and then we plug in the last number, which is the top number, 4. So it's telling you where to start, where to end, and then you just add them up. So 7, 9, 10. So 10 would be our solution. Okay, so that's a very simple one. All right, so then we get into a little more complicated things. So example 1 says find the sum. So we just use our equation. We're going to plug in 1, then 2, then 3, then 4. So this one happens to be the same number as my first example. So for x's, I'm going to plug in those numbers. So I'm going to plug in 1. So I'd multiply. 5 times 1 is 5 minus 1. That's going to be my first thing. Plus, well, let me make it smaller. So 5 times 1 is 5 minus 1. Plus. Now I plug in the next number, which is 2. So for x, I'm going to plug in 2 now. So 5 times 2 is 10 minus 1. Remember, order of operations, that's why I'm multiplying first, doing it one step at a time. Then I plug in 3, so 5 times 3 is 15 minus 1. And then 4, which is 20 minus 1. Okay, so then I simplify each parentheses, so each set separately. So this is 4, 9, 14, 19. If you need a calculator, this is where you would grab a calculator, you add them up, and you get 46. So that's the answer. Notice the sum is just a number at the end. Okay, so it's a weird thing to think about, but this is a common symbol in statistics equations. When we get into looking at equations, you'll see sum of some formula happens a lot. Okay, so the next one. Now we have n. The variable doesn't matter. Notice the variable in the equation changes, but it's the same thing. Now we're going to plug in 2, 3, and 4. Okay, it's a little more complicated, so I'm kind of just going to look at one thing at a time. 2 minus 1 squared plus 2. So I'm not going to simplify anything yet. Plus, now I plug in 3. 3 minus 1 squared plus 2. And finally 4. 4 minus 1 squared plus 2. Okay. So then I just simplify each one separately. So this would be 2 minus 1 is 1. Squared is 1 plus 2. This is 3 minus 1 is just 2. Squared is 4 plus 2. Then I have 3 squared is 9. plus 2. Notice I just add them all up. So I'd have 3 plus 6 plus 11, which is 20. And that's my answer. Okay, next one. So now I'm going from 2 to 5. This is cubed, so won't do that one in my head because a lot of people can't do cubes easily in their head. So it's 2, plug in 2. Now I'm plugging in 3, then plug in 4, and plug in 5. Okay. Order of operations, exponents come first. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And if you don't know those, it's fine. Use a calculator. In stats, you get to use calculators for everything. Okay, so you should be using a calculator for all this stuff. So I get 6 plus 25 plus 62 plus 123. I type that into my calculator, add all the numbers, and I get 216. And so that's finding the sum using capital sigma. Okay. So we also want to talk about, make sure you understand things. What if we did it the opposite way? Okay, so notice I always simplified things down to this sequence right here, right? It looks like a string of sums, a string of addition numbers, right? And each one of these things is from plugging in the first, then the second, then the third, then the fourth number, whatever it is, right? And so I did that for each one. So these problems are giving you the string of numbers. They want you to find the pattern, basically, and write out the sigma. So write in sigma notation. So what we had as our problem before should be our answer. So this first one, it's really simple. We got to look for a pattern. Okay, so I'm going to look what's happening between each number. Okay, I'm noticing that each number is going up by 3. That would give us a linear relationship. So if it's always changing by the same thing, it is a linear relationship. Hopefully you remember that linear graphs, right? It's y equals mx plus b. We're going to be using the mx plus b part of that if it's linear. Okay, we'll see once it's quadratic or cubic or something higher than that, it gets a little more complicated, and so we can't really use our equations we know. But linear is nice, simple, and we can use that equation we know, y equals mx plus b. Okay, so for this one, I know I'm going to have a sum because it's a whole bunch of additions. That's what sum means, right? A whole bunch of pluses. So I need to figure out the pattern to get to these numbers. Okay, this pattern is your slope. M represents slope, hopefully. That gives you your pattern. So if it's going up by 3, notice I put plus. That means it's a positive 3 slope. If it was going down every time, it would be a negative slope. Okay, so you do need to understand that. There can be positive slopes, there can also be negative slopes. If we're going up, positive, going down, negative. This one's going up, so it's a positive 3x. The b, we have to guess and check. Pretty quick. Most of these problems we write are not super complicated. So we're going to guess and check for the b. Okay. And that's also true of our starting number. Nice thing about linear, though, is we can technically start at any number we want. I always like to start at 1 because it's an easy number to plug in. So if I plugged in x equals 1, I get 3 times 1. That has to be giving me my first value here. 3 times 1 is indeed 3. So then I'd plug in the next number, which would be 2. 3 times 2 is 6. That's good. Then I plug in the next one. 3 times 3 is 9. That's good. And I plug in the last one. 3 times 4 is 12. So I'm going to end at 4 because that gives me, when I plug in 4 to my formula, that gives me the last problem. I'll put once I'm done, put it in parentheses so I remember that that's the formula. And we have it. Okay, so it's not meant to be super complicated. You got to look for a pattern and then guess and check. Plug in a number. Does it work? And then you got to plug in, figure out what would give you your last number. Okay, so we'll do the same thing. This is another linear problem. So it's going to be a sum again. Okay, so we got to look. What is happening? Notice the dot, dot, dot. That means it continues. The pattern continues until we get up to 48. Okay, so 48 needs to be my last number. This dot, dot, dot means there's a whole bunch of numbers in between. Just didn't want to write it out because it's the same pattern every time. So the pattern continues. And you notice we're going up by 5. -2 to +3 is up 5. 3 to 8, up 5. 8 to 13, up 5. So that is my pattern. That's my slope then. 5x is where we're going to look at. Okay. So this one doesn't work out as nice. So I'm going to start at x equals 1. It's linear, meaning it's nice to work with, basically. Linear functions are easy to work with. So when I plug in 1, if I plug in 1, 5 times 1 is 5. I want to have that first number as my result when I plug in the first x value. So plugging in my first x value does not give me -2. It gives me 5. So I got to think, how can I, using the plus b, so plus or minus, don't forget we can do negatives, change this so that my first result comes out to -2. So I got to think, if I have 5, how would I get from 5 to -2? Well, I'm definitely going to subtract. I got to go smaller. 5 is bigger than -2, so I'm going down. And I got to go down 7. Okay, so 5 minus 7 does indeed give me -2. Okay, then I need to check it. So the next number would be 2. So that should give me my second number here. So 5 times 2 is 10, minus 7 is 3. That's good. And then check the third one just to make sure. So I plug in 3. 5 times 3 is 15, minus 7 is indeed 8. Okay, so we got our pattern. So I'm going to put that in parentheses. That's my pattern. Last thing we need is the number where we're going to stop. So I need to stop when I get to 48. So there's a number that I can plug in for x that will give me 48 from this formula. Okay, so plug in easy numbers. So I know 10 is a really easy number to plug in. So if I plugged in 10, just kind of on the side here, I would get 50 minus 7, which is 43. That's really close. If you notice the pattern, you'll know that that is 5 off, so I need one more in my pattern, so I'm going to go to 11. 55 minus 7 is 48. So that is where they want us to stop. That means my last number I plug in is 11. Remember, it's not the number here. That's not the number you want out. It's the last number you plug in to the formula. Okay, so we got that one. A little more complicated, but still pretty simple. The last two, kind of the same things, just throwing a little twist at you. So the next one is fractions. It's basically 2. If you look at the top, you'll notice the top is doing plus 2 each time. If you look at the bottom, you get plus 1. So all it is 2 linear functions to deal with. Okay, so when I'm going through, I need a fraction line, one formula for the top, one formula for the bottom. Okay, don't make it too complicated. We're going to start at x equals 1 for both. They're both linears, so that's good. So let's do the top first. So my top, my pattern, my slope is 2. Okay, and I'll plug in. I'll get, when I plug in 1, and 2 times 1 is 2. Plug in 2, 2 times 2 is 4, 3, 2 times 3 is 6, and then plug in 4, so that's where I think I'm going to end. 2 times 4 is 8. So that one didn't have a plus b. Just worked right away on the top. Now I'm doing the numbers on the bottom, so 3, 4, 5, 6. This has a slope of 1, so you could write 1x. I'm just going to write x. Remember, if there's no slope, you assume it's positive 1. And if I plug in 1, notice it doesn't match up. So when I plug in 1, I get 1. I need 3. So how would I get from 1 to 3? Well, I add 2. 1 plus 2 equals 3. Okay, now I check the other ones. 2 plus 2 is 4. 3 plus 2 is 5. And then 4 plus 2 is 6. So that's my formula. Put it in parentheses. And there we go. And then we get to our last one. This one, we can look. You'll notice right away something's different. It's not linear. Okay, so it's either going to be linear, or if it's not linear, it's either going to be quadratic, which is squared, or cubic, which is cubed. Okay, if you look at these numbers, so notice my 5, 7, 9, they have a pattern. That means it's quadratic. So quadratic, you have a pattern in the pattern. Sounds funny, but it makes it really easy to pick out. Cubic will not have a noticeable pattern in the pattern. Okay, so if these numbers aren't going up by the same amount, then you know it's cubic. If these pattern numbers are going up by the same amount, then you know it's quadratic. So this one, it's 5, 7, 9. Each time it's going up by 2 inside my pattern, I know it's quadratic. So that makes things a little easier. When I write this, I know it's going to be squared. Okay, we're not going to get too crazy with you. We're never going to put a number in front of the squareds or the cubes like we did with the linears where we have the slope. Everything's going to become a little easier, but we might have to add or subtract things. Okay, and with quadratic, you're not always necessarily going to start at 1. So if we checked 1, okay, if I plug in 1, I get 1 squared is 1. I need to add 6 to get to 7. 1 plus 6 is 7, right? So that makes that first term work now. So 1 squared is 1 plus 6 is 7. Okay, I think it works. Plug in 2. 2 squared is 4. 2 times 2, 4. Plus 6 is 10. That's a problem. That didn't work. If I plug in 3, 3 squared is 9, plus 6 is 15. That one didn't work either. I am supposed to be getting 19. So that didn't work. That's the problem with quadratics and cubics, though. We don't necessarily start at 1. So you got to guess and check with the number as well. So now I go to 2. 2 squared is 4. So I add 3 to get up to my first value there. I am starting at 2, so I need to start. When I plug in 2, I need to get 7 out. So 2 squared is 4 plus 3 is 7. That worked. Now I need to go to 3. 3 squared is 9 plus 3 is 12. That worked. And if I check 4, which is the next number, 4 squared is 16 plus 3 is 19. That worked. So we found our starting number. A little more complicated than the linears. Right? If it doesn't work, you have to go back and change your starting number for quadratics and cubics. So now we got to just find the ending number. So I got to think what number squared is close to 67. Okay, so I know that 8 squared is close to 67. 8 squared is 64, plus 3 is 67. So there we go. We got our ending number, we got our formula. Okay. So the last thing you're going to have to do is write out the summary here. So you do have to write summaries at the end of each note. At the end of the unit tests, or at the end of the units, I guess not the unit tests, but the units, I will be collecting all these notes. You'll be taking pictures of your notes, whether it is on a piece of paper or on a printed out note set. It doesn't matter, but I need to see all of them in one file. So multiple pictures in one file uploaded to the Google Classroom assignment when we get to the end of the unit. So make sure you keep your notes and make sure you have them all filled out with all the summaries done. Okay. For your summary, I'll give you this one. So it's explaining what we did. Okay, so we need 3 sentences minimum. So the sigma in math means sum. Okay, that's the first thing, right? All right, and then what else did we do? So the first thing we did was we plug in and we added okay, to find the solutions. And then the second thing we did was we looked for patterns to write sigma notation. Okay, notice it's quite simple. You do need full, complete sentences. This is the only one I'm going to write for you. But I have 3 sentences just quickly explaining what we did. We just go back, kind of think, what did we do, and write a quick sentence about those things. Okay, a sentence or 2. So pretty simple. Make sure you are doing that for each notes on your own. This is the only one I'm doing for you. And remember, we're going to turn these in. This is a grade. So you want to make sure you have these complete and ready to turn in when I collect it. All right, that was sigma notation.